Okay, we got a lot of principle. I told you the other time about principle of experimental design, where we got blocking. You heard about blocking? We block when the experimental unit is heterogeneous in nature, and we need to. I remember I used an example on, is it quality of life for police? You remember where we compare, and don't forget police. If you want to consider the mode of work, some do of day shift, night shift, evening shift. So if I want to compare, if I want to see the quality of life, what I'm going to compare is those who do 8 hours, 12 hours, and so on like that, which means I would need to first partition the police into different blocks. Okay. So that's what I said, did the experiment follow principle? So your experiment that you design, you got to make sure it follow principle. Now, if everything okay, then we go into analysis. Okay. Let me tell you this. In data analysis, this is where we use appropriate statistical methodology. Okay. On the data. And there are so many statistical methodology around, but we got to make sure we choose the appropriate one. And that is why you are here. You are here, you study statistics, you actually offer some courses in statistics just for you to be statistically guided in terms of which method do I actually think is more appropriate for a particular data. Let me tell you this. The choice of statistical methodology actually depends on the nature of your data. Okay, now evaluate the study design with the data answer the research. Evaluate the analysis, correct the analysis if necessary. Let me tell you something. We got a way in statistics to evaluate the analysis. What are we evaluating analysis? We got a way to evaluate our model. Every statistical model has error components. Okay? Every statistical model has what? Error components. Okay? Every statistical model has error components. In fact, this is the reason why we normally write model as, if I have y equal the deterministic part of a model plus random parts. If this guy happens to be response, okay, response variable, so we believe that there's always going to be a random part in every statistical model. The presence of the random parts, why we got a random part? The random part is the error, because there's always going to be this guy, because of the fact that the model, okay, the model we're using is not the same as reality. Now, in model evaluation, we talk about evaluating the analysis. In evaluating analysis, what we evaluate is model. How do I know whether my model has done a great job? My model has done a great job. If I really want to know that, I'm actually going to revisit. That is why in a model, assumptions in a model revolve around the error. Does that make sense? Assumptions in a model revolve around the error. If I really want to know how great is my model, then I will need to investigate whether assumptions hold. So the moment assumptions hold, then my model is valid. Does that make sense? So a model, and that is why I normally say this, a model is as good as assumptions put into a model. What makes a model to be nice, what makes a model to be great is when there is no violation of assumption. Does that make sense? So that is a way to, that's why statistics as a course, as a discipline, is very, very interesting because we got a way to evaluate, okay, the correctness, okay, the validity of the model used. If you don't do that, if you don't do model evaluation and you just go into recommendation, then your recommendation will not see the light of the day. And that is the reason why at times it's going to look as if our models are failing us. Our models are not failing us. We are the one that we're not doing the right thing. And what is the right thing? The right thing is to do model evaluations. And doing model evaluation is about investigating whether assumptions hold. And you know what? Assumptions revolve around the error. I remember when you're walking about linear regression, oh, we're going to say, oh, we got assumptions of normality of residual. Oh, we got assumptions of constant variance. Okay, all of that revolve around the error. Okay, does that make sense? That's what we mean. Now, then after all of that is done after model evaluation, we can now interpret results. Okay, then when we interpret results, we can suggest next steps.